Right, another past examination question. So this is from Edexcel. It was a core mathematics question C4 from the year June 2008, and this was question number 2 of that paper. So let's have a read. Part A. Use integration by parts to find the integral of x e to the x. So let me attempt that problem here. So let me pick up my blue pen. So here's part A. So we're integrating x e to the x with respect to x. And let me write down the by parts formula. So here's the by parts formula. So here's the by parts formula. It's whenever you integrate u dv over dx with respect to x. So that will give us uv minus the integral of v du over dx with respect to x. Now, if you're unaware of integration by parts, I have created a video on integration by parts explaining the method, and I'll provide a link to that video in description below. But let me give you the idea of by parts though. The idea is we need to choose u and dv over dx so that v du over dx will be easy to integrate on the right hand side. So I'm going to take my u then to be x, and I'm going to take my dv over dx to be the remaining term e to the x. So it's our job to select u and dv over dx, but when we select those terms, so we need to select them in a way, in a sensible way, such that v du over dx here is easy to integrate. Now, let's do a side calculation. So u is x, that would make du over dx. So when I differentiate x, that's simply 1. So we need du over dx for the by parts formula, but we also need v. So dv over dx is e to the x. V then is the integral of e to the x. And when I integrate e to the x, I'll get e to the x. So that is v. So v is e to the x, du over dx 1. Now let's apply these into the by parts formula. So if I replace into the by parts formula, u, which is x, dv over dx e to the x with respect to x. So the left corresponds to the question, so it should correspond. That is equal to u is x, multiplied by v is e to the x, minus, so a minus integral, so the integral of v being e to the x, multiplied by du over dx, that being 1. So if I continue, so if I get rid of the brackets first of all, x times e to the x is x e to the x minus, so a minus, the integral of e to the x times 1 is e to the x with respect to x. And if I continue one more step, I'll have x e to the x minus, when I integrate e to the x, I'll get e to the x. Let's add a c since we have an indefinite integral. So for any indefinite integral, i.e. any integral without limits, be sure to add a c. So this should be the solution for part A. So part A done. Right, part B. Let's have a look at part B. Hence find the integral of x squared e to the x. So the word hence is a good clue. So that would mean that we'll need to use the answer of the previous part to help us with the current parts. So let me do part B over here. So we need to integrate x squared e to the power x with respect to x. Now to integrate this term, we need to use by parts. So let's integrate by parts. So by parts, let me write down the by parts formula. Whenever you integrate u dv over dx with respect to x, that would be uv minus the integral of v du over dx with respect to x. So once again, we need to choose u and dv over dx so that v du over dx is easy to integrate. So I'm going to take my u to be x squared. So my u is x squared. And that would mean that the dv over dx would be the remaining term. So if I take u to be x squared, dv over dx is e to the x. So for the by parts formula, we need du over dx. So let's differentiate. Du over dx, if I differentiate x squared, we'll get 2x. And we also need v for the by parts formula. So v is the integral of e to the x with respect to x, and that would be e to the x. So I have u, I have du over dx, I have dv over dx, and also v. We have everything for the by parts formula, so let's apply it. So when I replace u, which is x squared, dv over dx, which is e to the x, with respect to x, so that is equal to uv, u is x squared, into v, v is e to the x, minus, so a minus, integral of v, which is e to the x, whoops, so let me make it more neater, times du over dx, which is 2x, close brackets, with respect to x. Now let me go one stage more. So when I get rid of the brackets, x squared times e to the x, so that is x squared e to the x, minus, and when I get rid of the brackets within the integral sign, 2x times e to the x is 2x e to the x with respect to x. And let's go one stage further. So x squared e to the x. If I take this 2 out of the integral sign, so you can only take constants out of the integral sign. So if I take the constant 2 out of the integral sign, I'll have minus 2 into the integral of x e to the x with respect to x. Let's pause there for a moment. The reason for me taking this constant 2 out of the integral sign is that if I take my red pen, okay, this term over here is precisely the integral of x e to the x, which I have from part A, and we found a solution of that from part A, and the solution of which was x e to the x minus x plus c. So going back to the question for part B in particular, that is the reason why they use the hence. So we're going to be applying that answer to this current part. So let's use the answer from here in order to go one stage more. So if I go to my favourite colour blue, we'll have x squared e to the x. So x squared e to the x minus the 2. So minus the 2. Open a bracket, the integral of x e to the x with respect to x, we found that from the previous part, we had x e to the x minus e to the x, so x e to the x minus e to the x, close bracket. Since our integral on the left doesn't have any limits, i.e. it's an indefinite integral, let's just add a c. So let's multiply the brackets from here. So x squared e to the x from the first term, minus 2 times x e to the x, so that will be minus 2x e to the x, minus 2 times minus e to the x is plus 2 e to the x plus c at the end. So that I believe to be the solution to part B. So not only that completes part B, that completes the question in its entirety. So I hope you enjoyed this video. I hope you liked the video. If you did enjoy the video, be sure to like and subscribe, and I hope to see you again. Thank you.